वेलकम टू वेदादी क्लासेस। वेदादी क्लासेस में आपका स्वागत है। टुडे वी विल स्टडी द चैप्टर हाइड्रोकार्बन ऑफ क्लास 11th. In last video we have covered the preparation of alkanes. In this video we will cover the physical and chemical properties of alkane. So what are the physical and chemical properties? So we will discuss over here. So let's start with the physical properties. So in physical properties of alkane, what you write? Physical properties of alkane. So what's about the physical properties? In physical property we study about the boiling point, melting point, solubility, just density. So these are known as the physical properties. So for the boiling point, so there is some basic concept. Boiling point is directly proportional to molecular mass. So more the molecular mass, more it will have the boiling point. And boiling point is also directly proportional to the surface area. So more the surface area it will be the more boiling point of that compound. Have a look here. Suppose I just give you some examples so it will clear your concept. Like in case of CH3, CH2, CH3, CH3 and CH3, CH2, CH3, which will have the more boiling point, then obviously this have the more carbon, it will have more molecular mass, so it will have the more boiling point, isn't it? Now let's start. Let's think about the isomeric alkane. Isomeric alkane is what? Isomeric alkane. So if you remember, then alkane have chain isomerism. So I just like to give you one example. So with the help of example, it will clear. So we take CH3, CH2, 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 CH3. This is the 5-carbon alkane, and 5-carbon alkane is known as? 5-carbon alkane is known as? Very good. So is the N-pentane, is the normal pentane we have. Now, so if the branching will take place, so if there is a one side branching from the middle carbon, so it is known as isopentane. And if the two sides branching from the middle carbon, this is known as neopentane, as we already know because we have discussed in the IPC nomenclature. So this is the neopentane. This is your neopentane. Now have a look here. What's happening? All have the same number of carbon, same number of hydrogen. So all will have same molecular mass. Now in this case, what do you think? Which will have the more boiling point and why? So have a look here. We have this concept. What the concept is? Second one, the boiling point is directly proportional to surface area. Boiling point is directly proportional to the surface area, and out of these, which have the greater surface area? Then this normal pentane have the greater surface area, so this will have a more boiling point. Now in between these two, iso and neo, iso have the more surface area, so it will have more boiling point as compared to the neo, and the neo will have least boiling point because out of these three, this have least surface area. So this is about the boiling point. Now have a look here. We have to discuss about this next one. Next one is the melting point. Next one is melting point. That's good. So what's about the melting point? So wait a second. So melting point is what? Melting point is also directly proportional to molecular mass. So the alkane which have more molecular mass, that will have a more melting point. But there is a concept that is known the alternation effect. So alternation effect is what? Alternation effect. So this is very important concept, alternation effect. So what the alternation effect we have? So alternation effect is suppose we have a odd number of carbon and the even number of carbon. So out of odd number of carbon and even number of carbon, which will have the higher boiling point, then even number of carbon will have even number of carbons alkane will have higher melting point as compared to the odd number of carbon atoms. Okay, how? Have a look here. We just take the example of even number of carbon atom. So even number of carbon atom, we just write here the even number of carbon atom. So this is suppose we take hexane, n-hexane. So hexane can be written as CH3, CH2, CH2, CH3, CH2, 1, 2, 3, 4, 5, and this is the 6 over here. Nah? So this is the even number of carbon. Odd number of carbon is what? Now we take the 5 carbon. So 5 carbon alkane, CH3, CH2, CH2, CH2 and CH3. So this is the 5 number of carbon. So this is the odd number of carbon atom. So this is the odd number of carbon atom. So out of these two, this will have a higher melting point. So why this is so? And this will have lower melting point. So why this is so? Then odd number of carbon atom have the higher lower melting point and even have the higher melting point. So there is a static hindrance. The concept works static hindrance. Now have a look here. This is the polar carbon. Now, so they are at a very maximum distance. So repulsion between these carbon is very less. So it will have a higher melting point. Now, so it will more stable as compared to this one. This polar carbon are very close to each other, and so it will have a more repulsion, and so that's why it will be less stable, and so it will have a lower melting point. Now, in the similar way, I just like to give you one more thing. That is the solubility. Next property is the solubility. Solubility is what? Solubility is the next one. Solubility. For the solubility, you should keep in mind that the concept is like dissolves like. Like dissolves like. It means polar dissolves polar, polar dissolves polar, and the non-polar dissolves non-polar. Non-polar dissolves non-polar. Now have a look here. Alkane is what? Alkane is polar or non-polar? So obviously alkane is predominantly non-polar. Alkane is what? There is no electronegativity difference. So alkane is predominantly non-polar. This is what? Non-polar. So, and water is what? Polar. So do you think it will dissolve, alkane will dissolve in water? No? So no, it will not dissolve in water and alcohol, because water and alcohol are polar in nature. So alkane are insoluble in polar solvent like water. Alcohol is also a little bit polar, so we can also write alcohol. So whereas now organic solvent. What the organic solvent we have? We have the organic solvent like petroleum, ether, benzene. So these are what non-polar in nature. So alkane is soluble in organic solvent. What's about the organic solvent? Like example criteria we have like petroleum, ether, ether, benzene. These are what? Organic solvent. These are what? Organic solvent. Na? And carbon tetrachloride, CCl4, etc. So that's why. So this is the concept about the solubility. Na? And now we'll next study about the fourth one. The fourth one which we have, density. Density is what? Density. So we have to compare the density. So density is what? Densities of alkane increases with increase in molecular mass, because density is equal to mass by volume, and so density increases with increase in molecular mass. So molecular mass density will increase with the increase in molecular mass. So simply we can say density is directly proportional to molecular mass. This is the thing you should keep in mind. So all alkanes are lighter than water. This is very important fact. Then all alkanes are lighter than water. So this is about the density. Now basically density of alkanes, it is a limiting value about 0.8 gram per centimeter cube. So that's why it is lighter than water. Now we'll just move towards the chemical properties. So chemical properties, we have finished this physical properties. Now with the chemical properties, so what's about the chemical properties? So chemical properties is what? So chemical properties, we say of alkane. Alkane is what? Alkane is also known as paraffins. It is also known as paraffins. So what is the meaning of the paraffins? Paraffins means little affinity, means less reactive. So para means little, and affins means affinity. It comes from affinity. So it have a less affinity, so it means it's a less reactive, you can say. So now let's start with the different types of chemical reaction of alkane. Then first one is halogenation. So halogenation of alkane is very important. So halogenation means what? Reaction with halogen. So what's about the halogen? So halogen, we have like fluorine, chlorine, bromine, iodine. So these are known as the halogens. So and out of these, what's about the reactive order of the halogens? So reactive order of halogens, we should keep in mind, which is more reactive than fluorine is more electronegative, so it is more reactive than chlorine, than bromine, and then finally is the iodine. Now let's start with the chlorination first. So let's move towards the chlorination. So chlorination of let's start with the chlorination of methane. So chlorination of methane. Methane is an alkane, so we do the chlorination of methane. Now have a look here. So we just take the CH4. The chlorination takes place in presence of sunlight. Sunlight is also represented by H nu, or simply we write sunlight. So what will happen over here? So one HCl will out, and it will form CH3Cl plus HCl, and this is known as chloromethane. This is first product is chloromethane. Now next one is what? Next one again this chloromethane will it will react with the other, it will undergo chlorination. Further chlorination in presence of sunlight. So what will happen? One HCl will out from here, and it will form CH2Cl2, CH2Cl2 plus HCl, and this is the dichloromethane. What do you say? Dichloromethane. Now again this dichloromethane will undergo this dichloromethane undergoes chlorination. So if it will undergoes chlorination, then what will happen in presence of sunlight? So one HCl is out, then it will form CHCl3 and plus HCl, and ClCl3 is known as trichloromethane, or simply it is known as chloroform. Chloroform is used as anesthesia. It was used as anesthesia, not now. Why it is here the question, why chloroform is banned for using as an anesthesia? Okay, can you give me the answer? This is known the trichloromethane. Methane over here, and again the trichloromethane will undergo. What I asked the question? I asked the question, why chloroform have been banned to use as a anesthesia. So earlier the chloroform was used as a anesthesia during the operation and like this, so by doctors, but now it is banned. Why this is so? Because chloroform is very sensitive towards the light and the air, so it get oxidized easily into the phosgene gas. So phosgene gas is very poisonous in nature. So if somebody is you know one thing, that there is a specialist, anesthesia specialist doctors, he is only called during the operation only to measure the amount of chloroform or the anesthesia that should be given to the patient for the whatever the time period for that, to make them unconscious. So now if in place of chloroform, if the oxidized chloroform, that is phosgene, is can be given to the patient, then he can die. It happens so many times. So to avoid such type of dangerous situation, chloroform have been banned. Now in place of chloroform, some other ethers have been used as are used as a anesthesia. Now just move towards chloroform. For the chloroform also get chlorinated, then chloroform Cl, Cl, and H, so it will also get chlorinated. And what will happen? This HCl is out, and finally it will form carbon tetrachloride and plus HCl. So this is the chlorination of methane. So it will give you 4 products. How many products it will give you? So one is the chloromethane. This is 1. Other is the dichloromethane, this is 2. Other is the chloroform, that is the trichloromethane 3, and other is the carbon tetrachloride. This is not the carbon tetrachloride. Carbon tetrachloride, or we simply say tetrachloromethane. Okay, now so now we just move towards the next part. Next part is very interesting. This is the mechanism of halogenation we should know. So what's about the mechanism of halogenation? So do you know the mechanism of halogenation? So now I am going to explain this. What is the mechanism of halogenation? Alright. So the first one is step 1. In step 1, this is known as chain initiation. So what's about the chain initiation? So basically the chlorine which have taken in presence of sunlight, it get break down into the free radical. This is the chlorine free radical. What do you say? This is the odd electron is over here, then this is known the chlorine free radical. Free radical. Now what? If the chlorine free radical you get, then there will be second step. That is the step number 2. Step number 2. I have one more thing, that in place of sunlight, you can also it can also be heated by 520 to 670 Kelvin temperature. So it gives a homolytic cleavage. This is not the homolytic cleavage. This is what? Homolytic cleavage. So what the homolytic cleavage is? What homolytic? Same breaking into the forming the free radicals. They take their own electrons and they form they become free and form the free radical having odd electron. Now chain propagation is what? What's about the chain propagation? Second step is the step 2 is the chain propagation. So what's about the chain propagation? So when you talk about the chain propagation, then the methane, suppose we are doing the mechanism of halogenation of methane. So we just take the methane and the methane will react with the odd electron free radical chlorine, and what will happen, reaction will proceed just like this. Carbon is more electronegative than hydrogen, so it will take the shared pair of electron, and this odd electron chlorine or the free radical will get attached to this hydrogen and it will form HCl. Now what will happen? Now this is methyl and this is this have taken its own electron, so this will what? Now I just saw like this one. This one is what? Is they are taking the one electron. Singlet. What is a singlet bond? So it's a singlet. I am showing the singlet one. So this is a singlet one. Now it also form a singlet. Singlet is what? Singlet means 1 1 1. This is the singlet one. Now so it will form methyl free radical. It is the methyl free radical. Methyl free radical. In second step, which is known as the chain propagation, methyl free radical is formed. Now what? So now in the step 2 only, this methyl free radical will again react with the chlorine. Chlorine is not only a single molecule, a number of molecules is there. So with the available chlorine, so it will just join with this one and it will form CH3Cl, and this is the chloromethane, and again you got the free radical. So this is the methyl chloride, you got methyl chloride. Now so this is the methyl chloride you got. So there is some more possibility like what? Then this CH3Cl will again can combine with a free radical and can form CH2Cl free radical plus HCl, and there is some more possibility like this CH2Cl plus Cl2 again, then it will form CH2Cl2 plus free radical. Again it got the free radical. So if you got the free radical, then what will happen in the next? So it can combine with the CH2Cl2 plus again this free radical, then it will give you the CHCl2 with a free radical and again HCl. Now what will happen? This free radical will again react with the Cl2 and it will form CHCl3. This time is the chloroform is formed. Again one free radical is there, and again this CHCl3, this chloroform CH3 will react with the free radical and it will form what? CCl3 free radical plus CCl3 free radical plus HCl. HCl is formed over here, and again this free radical CCl3 will combine with Cl2 to form what? CCl4 carbon tetrachloride and plus Cl as a free radical. So all this progress happens in chain propagation. Now what's about the next one? So next one is step 3. Step 3. In step 3 what will happen? Then this step is known as chain termination. chain termination. So what's about the chain termination? So whatever the free radical is there, they can combine to form a new molecule. Like what the free radicals left, so a lot of free radicals of chlorine that will combine to form Cl2. A lot of free radical of methyl is there, then they can combine to form ethane, 2 molecule, then C2H6 they can form. And whatever the free radical of methyl plus free radical of chlorine, that will form CH3Cl. Have you noticed one interesting thing? What is the interesting thing? Then we are doing the chlorination of methane, but during the chlorination of methane we also formed ethane. So during the mechanism of this one, so chlorination of methane forms ethane as a byproduct during the chlorination of methane. This is very important one, you should keep in mind. Then during the chlorination of methane, what is formed as the byproduct? Ethane. What? Ethane. That's good. So now let's this is the halogenation part. Now we'll just move. We have this is the chlorination. Again, the bromination also takes place, and the iodination at and also the fluorination is also took place. Have a look here. I just like to explain everything now. Now, if the bromination is there, then what? Bromination. So if the bromination is there, then what will happen? In the bromination, then suppose we have taken the CH3, and the bromination will take place in presence of sunlight, or this is the sunlight. So it will form what? It will form CH3, CH2Br, methyl bromide, and plus HBr as a byproduct. Now we can write the CH3, this is the ethane, ETHANE. Ethane is what? CH3, CH. We can write CH3, CH2H, and this is the Br. So one HBr is out, and one Br will get attached, so it will form bromoethane. In the similar way, iodination also takes place. Iodination. So iodination is basically simply we can form like we have the methane or something with the iodine, then it can form the CH3I and plus HI. So this is the iodination thing. So you should keep in mind. So direct iodination of alkane cannot be brought about. This is very interesting. Direct iodination of alkane cannot be brought about. What we do for iodination? So we use some oxidizing agent like iodic acid. So I'm just writing a note. So note is what? Direct iodination. Direct iodination is not possible. Is not possible. So what we do for that? So we use some oxidizing agent. Oxidizing agent, like whatever the oxidizing agent, like iodic acid, HiO3, like HiO3, or a nitric acid, HNO3 is used to proceed the iodination. So this is a very important thing. So you should keep in mind. Now next one we have the fluorination. So what's about the fluorination? So fluorination is what? Fluorination. So direct fluorination is a direct fluorination is a very vigorous reaction. Alkane is too vigorous to control under ordinary condition. So that's why pure fluorine is a fluorination of alkane can be carried out by diluting the fluorine with an inert gas such as nitrogen or argon. Or the alkyl fluoride can be conveniently prepared indirectly by heating the other alkyl halide with fluorinating agent. And this is known as a SWART reaction. This is what? This is known as a SWART reaction. SWARTS, SWARTS reaction. So SWARTS reaction is what? This is the name reaction, you should keep in mind. So when alkyl halide, what you write? When alkyl halide alkyl halide reacts with what? So when alkyl halide reacts with a fluorinating agent, what the fluorinating agent? Which fluorinating agent will you use? That AgF, silver fluoride. We can use antimony fluoride. You can use mercury fluoride, Hg2F2 you can use, and you can also use arsenic fluoride. Now any one of these you can use as a fluorinating agent. So what will happen? So how the reaction will proceed? So see the reaction like Rx we have, and plus AgF, then it will give you what? AgX is out over here, and it will form RF, alkyl fluoride, plus AgX. Now have a look here. Like what happens when methyl chloride? Now what happens when ethyl chloride? Now here the question. What happens when ethyl chloride reacts with AgF, na? So or mercurous fluoride, So what the mercurous fluoride? That's the Hg2F2. So we just take the example like 2CS3CH2Cl. This is the ethyl chloride, plus we just take the AgF. Only one AgF is required. This one molecule is sufficient. So AgCl is out, and it will form CH3CH2 F, ethyl fluoride, plus AgCl. Now again, if you want to take the mercurous fluoride, then you have to take two molecules. So how it will take? So like CH3CH2Cl, 2 molecule, plus Hg2F2. So it will give you what? 2 molecules of CH3CH2F, ethyl fluoride, plus Hg2Cl2. This is the mercurous chloride you will get. So this is all about the halogenation of alkane. Now we'll just move to the next one, and the next one is the nitration. Next one is nitration of alkane. So nitration, what do you give the headline? Nitration of alkane. So nitration of alkane is what? So nitration of alkane, wait a second. So nitration of alkane, we just do the nitration of alkane. So basically this is the replacement of hydrogen atom by nitro group, na? So replacement of replacement of hydrogen atom by nitro group. Nitro group is what? NO2 group. So simply what the thing is, we can write when alkane react with what? Nitric acid, fuming nitric acid. So what happens? You take this some particular temperature like 673 Kelvin temperature. At 673 Kelvin temperature, it forms nitroalkane. Na? So wait a second. So the thing is what? This is nitroalkane. It will form like I just like to give you some example like methane. Methane can be written like CH3H, and HNO3 can be written like HNO3. For easy way, we can write here the OHNO2. Like this is also the HNO3. This is HNO3. So what will happen? H2 is out from here. H2 is out, and this NO3 will get attached with the CH3, and CH3 NO2. This is the nitromethane plus H2O. This is the nitromethane, methane, and this is what? H2O. Got it? So in the similar way, we have when you take the ethane, so it also gives a mixture of product. So it also gives a nitroethane and a nitromethane. In the similar way, when the propane undergoes reaction with the fuming HNO3, then it gives a mixture of product, like it will give you nitropropane, 2-nitropropane, the nitroethane, nitromethane. So that's why. So this is about the nitration of alkane. So now we just move to the next one. Next one is the sulfonation. So sulfonation is what? Sulfonation is reaction with the conc H2SO4. So sulfonic acid, sulfonation. So sulfonation is reaction with what? H2SO4. So basically these are very reactive for the higher alkanes, which have 6 or more carbon atom. So now the thing is what we just take the example of N-hexane. We take the N-hexane, or anything we take, like the CS3. This is the CS3, and this is H. So this is the 3-methyl propane. This is what? 3-methyl propane. When it undergoes the reaction with the H2SO4. So what it will form? Sulfonation will give you what? Sulfonic acid. What it will give? Sulfonic acid. How it will react? Then it will react with the H2SO4 and at 675 Kelvin temperature. H2SO4 can be written as HOSO3H. Is correct? So H2 is out from here, and just it is replaced by SO3H. So it will form over here like this, and this is SO3H over here, and plus H2O. And what the name? The name is this is the 2-methyl, not the 3-methyl. So this is the 2-methyl. So this is also the 2-methyl propane, and at second position, 1, 2, 3. Second position is sulfonic acid. So 2 sulfonic acid. Now, so this is the thing. Now the next reaction, this is next reaction what we have, that is known as oxidation. Oxidation is also different type. Oxidation, how many different types of oxidation? So one oxidation is complete oxidation, that's the combustion. Now it is not the complete oxidation. Other one is what? Other one is now known as incomplete oxidation. Incomplete oxidation. And the next one is which one? Is the catalytic oxidation. Catalytic oxidation, in presence of catalyst it took place. And so these 3 types of oxidation we have. Now we'll just discuss about one by one. So the first one is what? Complete oxidation. That is not the combustion. This is combustion. So complete oxidation is known as combustion. So what the combustion is? So combustion of alkane. Now complete oxidation of alkane gives complete oxidation of alkane. Always gives what? CO2 plus H2O, and plus heat plus light, as it is. So have a look here. Now we just take the CH4. CH4 will oxidize, then it forms CO2. All alkane will give you this CO2, H2. You have to balance it. That's the other thing. So one carbon dioxide, and 4 hydrogen, then 2 H2O, then 4 oxygen, then 2 O2 over here. Now C4. Now there is one more way to balance this complete oxidation. So the molecular formula for alkane is HCnH2n plus 2. This is the molecular formula of alkane. So plus 3n plus 1 divided by 2, and this much oxygen you will take, and you will take n number of carbon dioxide and n plus 1 of H2O. That's simple. It's very simple. How? Have a look here. I just like to give you the 5 carbon alkane. So put the 5 over here in place of 5. Then C5H2 into 5 plus 2. So 5 carbon alkane is pentane. So C5H12. Now when it undergoes oxidation, how many oxygen you will take? So this much oxygen you have to take now. This, so 3n plus 1. So 3 into 5, 15, 15 plus 1, 16, 16 divided by 2, 8. Then 8 oxygen, 8 O2 you have to take. And how many carbon dioxide form? How many n is? 5. Then 5 carbon dioxide will form. And n plus 1, matlab 6 H2O will form. It's a very simple one. So this is a very interesting thing. So you should keep in mind. So combustion of alkane basically like are used in the fuels like gasoline combustion, kerosene oil combustion, petrol combustion. So these are petrol, gasoline, diesel. These are what? LPG gases. These are what? All other alkanes. And combustion will give you the fuel, heat and energy. So this is the first one, the combustion we have discussed. Now we'll just move towards the incomplete combustion. So what's about the incomplete combustion? So incomplete combustion. Incomplete oxidation we say. Oxidation. So incomplete oxidation is what? Complete oxidation gives CO2 plus H2O, and incomplete oxidation will give you in a limited supply. It happens in limited supply of air, in limited supply of air. So this is the limited supply of air. What it forms carbon monoxide. It forms carbon monoxide and unburnt carbon it gives. Like suppose incomplete combustion of methane, then CH4 plus 3O2, you just take, balance it, then it will give you CO plus 4H2O. So it gives you carbon monoxide, and limited again CH4 plus O2, it can give you carbon black, that is C plus 2H2O. So it gives carbon monoxide and unburnt carbon, that is the carbon black it gives you. So this is the incomplete combustion we have. Now we have to discuss about which one. One more thing. Reaction with steam. Reaction with steam. When alkane is alkane like methane react with the steam like H2O, then what will happen? That in presence of nickel catalyst at higher temperature, it will give you CO plus H2, and this is known as synthesis gas, synthesis gas. What do you say this? This is the synthesis gas or syn gas. You should keep in mind. So basically this is the method of preparation of dihydrogen, that's a H2 on industrial at a large scale at industrial in the industrial preparation. Now we'll move to the next one. Next one is what? Catalytic oxidation. Which one? Catalytic oxidation. That's good. So catalytic oxidation. So catalytic oxidation have a different criteria. With different catalyst, alkane forms different product. Like, have a look here. Where I just give you the example. Like methane is oxidized in presence of in presence of cooperative. It moves cooperative at 100 atm high pressure and 573 Kelvin temperature. Then what will happen? So it will give you the alcohol. So it will give you CH3OH. So you should keep in mind, in presence of cooperative, So oxidation of methane, it will give you methanol. It will give you what? Methanol. Na? It is very poisonous in nature. Na? So it can lead to the brain, it disturb your nervous system, and always it is blindness. It causes blindness, as well as it may be fatal if it is consumed at the large scale, isn't it? So that's why. Now the next one, if you take the if oxidation of methane took place in presence of molybdenum oxide. This is not the molybdenum oxide, MO2O3. Now, when it is heated, then what it forms? It forms formaldehyde. It forms one carbon aldehyde. That's the formaldehyde is formed. So very interesting. Formaldehyde, or we say methanol. Methanol. One carbon aldehyde is known as methanol. That's good. So this is a methanol is formed at when the molybdenum oxide is used. Now next one, when higher alkane is oxidized. This is the higher alkane. For higher alkanes when oxidized, when oxidized, wait a second, this is O2. When oxidized in presence of Ag2, silver oxide, then what it form? It form corresponding carboxylic acid. So carboxylic acid can be formed with the alkane when it is oxidized in presence of silver oxide. So this is very important one. So you should keep in mind. Now next one is what? Next one, the catalytic oxidation. So if in general, if K-4 and K2Cl2,7 have been taken for the alkane, it can form alcohol. Like we have the tertiary butyl. This is the tertiary butane or isobutane. Sorry, this is the isobutane or 2-methyl propane, or this is the isobutane. And when it is oxidized with what? Oxidized in presence of alkaline KMnO4 or K2Cl2,7. This is a powerful oxidizing agent. Then it will get convert into what? It will get convert into alcohol. So it will form CH3OH, and this is known as tertiary butyl alcohol. This is what? Tertiary butyl alcohol. Alcohol will form tertiary butyl alcohol. Getting the thing? Samajh mein aa raha hai? It's good thing. Now we will move towards the next one. The next one is we have isomerization. Isomerization is what? Isomerization means conversion of one isomer into another. So when straight chain alkane get convert into branch chain, straight chain alkane get convert into branched chain alkane, means one isomer into straight chain means normal alkane get convert into branch chain, means it may be the iso or the neo, whatever, in presence of some catalyst. So what the catalyst we use? So we use the catalyst that is the AlCl3 and SCl. And SCl. So in presence of AlCl3 and SCl as a catalyst, so it will get converted into one isomer into another, means normal into alkane. So have a look. I just like to give you the example like CH3, CH2, CH2, CH3. This is what a normal butane. So N-butane we have, and N-butane in presence of AlCl3 and SCl. So what it will give you? So it will give you CH3, and this is the CH3 and CH3. So this is what? Isobutane. We have got it. Now, so these are the isomerism we have. Now one more we have, that is known as aromatization. What is the aromatization? So aromatization is what? Conversion of alkane into aromatic compound. So conversion of alkane into aromatic compound. Aromatic is what? Which have benzene ring, na? Into aromatic compound. Aromatic compound. So this is known the aromatization, and this took place in presence of some catalyst. So what the catalyst we use for the aromatization? So catalyst is used chromium oxide. CrO3 is known as chromium oxide. V2O5 is known as vanadium pentoxide, and molybdenum oxide is what? MO2O3, and Al2O3 is what? Alumina is what? Alumina. Na? And what the temperature we use? So temperature we use, that is 773 to 773 Kelvin is the standard temperature. So we use 773 Kelvin. And what the pressure we use? Pressure is very high. So what the high pressure is? 10 atm to 20 atm. 10 atm to 20 atm pressure. This is very high pressure we use. Now, when alkane is getting converted into aromatic compound, that's you can say the benzene or the toluene. Have a look here. This is a very interesting question, and some direct question come from here. So have a look here. When you take the N-hexane can be written like CH3, CH2, 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 4, 5 and 6. Now this is the N-hexane you have taken. This is your N-hexane. N-hexane you have taken CH3, 1, 2, 3, 4, 5, 6. So normal hexane. So this is your N-hexane. So when N-hexane is oxidized with is heated with Cr2O3 or V2O5 at 773 Kelvin temperature and 10 to 20 atm pressure, then first it will form cyclohexane. It will form cyclohexane just like this. Cyclohexane is what? Like this. This is cyclic compound will form. So cyclohexane will form first. This is everywhere this carbon, and each carbon have 2 hydrogen. How many hydrogen? 2 hydrogen. How many hydrogen it have? 2 hydrogen. So its molecular formula is what? N-hexane have the molecular formula C6H14. Now, but in the cyclohexane, this is C6H12 now. Now what will happen here? Now the next process is what? This will when further it is heated, so it will lose 3H2. When it will lose 3H2, it will get converted into benzene. This is your benzene, that is having a cyclic compound having alternate double bond, and this is your benzene. Benzene have molecular formula is what? C6H6. That's called. So with the help of N-hexane, it get converted into benzene. Now I'm giving you a question. What the question is, how we'll get, which alkane we will use to get toluene? Toluene is what? Benzene having CH3 is known as toluene. Is what? Toluene. So toluene is what? Methyl benzene is known as toluene. Methyl benzene is known as toluene. So what do you think? Which what alkane you have used over here? So basically we will use the N-heptane. Is what? N-heptane is the 6 carbon and 1 7 carbon. So 7 carbon alkane we have take. We will take the CH3. Then this is what? CH2 over here. Then CH2, 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 CH2 and CH3. So for the first, what will happen in presence of Cr2O3, then it will what? It will give you methyl cyclohexane. This is methyl cyclohexane, and for the dehydrogenation takes place, removal of hydrogen takes place, and it forms what? Methyl benzene or toluene. So this is all about the aromatization. Now have a look here. We'll just move to the next reaction, and next reaction is the pyrolysis. Pyrolysis is what? Pyrolysis is thermal decomposition. Means alkane get decomposed into a smaller alkane by heating. Now pyrolysis is what? Thermal decomposition. This is what? Thermal decomposition. So what happened in thermal decomposition? So the higher alkane get break down into a smaller one. That's it. So like C6H14, this is hexane. What is the hexane? When hexane is heated at 773 Kelvin temperature and 6 to 7 atm atmospheric pressure, then it can give C6H12 plus hydrogen, or it can also give C4H8 plus C2H6. Now means butane plus ethane, or there's other possibility, it can give you C3H6 plus C2H4 plus CH4. Means hexane can break down into propane, ethane and methane. So there is three possibilities over here. This is known as thermal decomposition. Now, so this is very important one, so you should keep in mind. Now, so in this way, this chemical properties of alkane is finished. Now I'm going to make a flow chart for you, so that you can remember all the chemical reaction at one place. So this is your alkane, this is RH. What is the RH? Alkane is what? RH. Very good. Now have a look here. So this is what we take over here. This is just like this. This is the flow chart. So the first reaction was halogenation. So halogenation, simply we just keep in mind the chlorination of methane. So chlorination methane will give you CH3Cl plus CH2 Cl2 plus chloroform CSCl3 plus CCl4, just like this in presence of sunlight. So this is the first reaction. Next one with the SWOT reaction. SWOT reaction with what? With AgF. Now AgF or any alkyl halide with AgF or Hg2F2. Now it gives you what? It gives you alkyl fluoride. Now so this is what this is known as SWOT reaction. So you should give this the name reaction. Name reaction is very important one. So this is SWOT's reaction. So SWOT's. There is one more, the iodination of alkyl halide, that's known as Finkelstein reaction. Finkelstein reaction we will study. What is the Finkelstein reaction? Finkelstein reaction. Finkelstein reaction is what? When any alkyl halide react with sodium iodide, and so it will convert into alkyl iodide plus what? NaX. So this is the iodination is known as Finkelstein reaction, and fluorination is known as SWOT reaction. So I can write here again one, if the alkyl halide will react with sodium iodide. Now this is known as Finkelstein reaction. So you have two Finkelstein reaction. So Finkelstein reaction will give iodide, alkyl iodide. Now the next one we have. Next one is which one? Next one, iodination, chlorination. We did it. Then after we have nitration. Nitration is what? Nitration with HNO3. So nitration with HNO3. So it will give you nitro compound, nitroalkane. Now again with the sulfonation. Sulfonation is what? Sulfonation. Sulfonation with H2SO4. Sulfonation means with H2SO4. Nitration means with HNO3. HNO3. So it will give you nitroalkane is what? Nitroalkane, and this is alkyl hydrogen, alkyl sulfonic acid. This is the SO3H. This is the alkyl sulfonic acid. Sulfonic acid. It will give you. Now the further we have one more reaction, that is the complete oxidation. That's the combustion. Complete oxidation is known as combustion. So combustion will give you CO2 plus H2O, and heat is always released, also the light. Now combustion is incomplete oxidation. Incomplete oxidation. So incomplete oxidation, it will give you what? Either it will carbon monoxide, or it will also give the carbon black. And this is now the catalytic oxidation is very important one. So catalytic oxidation, I just like to make over here, this side. Wait a second. Catalytic oxidation first in presence of copper tube and high pressure. It will give what it give. Suppose we just take the methane, sun methanol, and with the next one with the molybdenum oxide, oxide MO2O3, MO2O3, it will give you formaldehyde. What it will give you the formaldehyde with methane, with higher alkane, with a in presence of Ag2O. What it will give you? Carboxylic acid. What will give you? Carboxylic acid. Very nice. And there is one more, that's the in presence of alkaline KMNO4. What it gives? So if it is a tertiary alkyl, it is just like this, then it will go give you tertiary butyl alcohol. Now like this. Now some more we have. So let's start the other one is the isomerization. So what's about the isomerization? Isomerization took place at what condition? It take place in AlCl3 and HCl, in presence of AlCl3 and HCl. So what it gives? So it gives iso compound. Iso compound we can write with the middle carbon. There is a one side branching like this. So it will be isomerization. And the next one is what? Next one is what? Aromatization. Aromatization means it will form aromatic compound in presence of what? In presence of V2O5 or Cr2O3. Nah? Like this. This is what will give you. It will give you aromatic compound like benzene, or it will also give toluene. Nah? Hexane gives benzene, and heptane gives toluene. That's the methyl benzene. So this is the aromatization. And last but not the least, I am writing a pyrolysis over here. Pyrolysis means thermal decomposition. Bigger molecule will break down into a smaller one, like hexane will break down into C6H12 plus hydrogen, or it will break down to C4H8 plus C2H6, like this. So simply thermal decomposition is known as. So in this way we have finished the preparation and properties of alkane. Next we will start the alkene, and we will also discuss the stereoisomerism over there, because stereoisomerism have the conformational isomerism and configurational isomerism. Conformational isomerism part of alkane, and configurational isomerism like geometrical isomerism part of alkene. So we'll make a video for the stereoisomerism separately, but now in this continuation, in next we will start with the alkene. So you have to revise everything. So till then, take care of yourself and revise everything what we have studied. So take care of yourself, and goodbye.